what we're going to do today is sketching sine and cosine graphs. Okay, we'll learn tangent graph later. So sine, cosine graphs. I hope everyone knows what the basic sine graph looks like from last year. Just give you a little bit idea on what a sine graph and cosine graph looks like. Well, if not, that's fine. That's what the sine graph looks like. And the bottom one is what the cosine x looks like. Y equals to sine x and y equals to cosine x. It's a base, like that looks exactly the same. If you think about the first one to the second one, there's only a translation to the left by pound to unit. Okay, so first one to the second one, well, it can keep going. Okay, it can keep going because this is for one period. Okay, this is for one period. The rest of the graph for sine x, you can see I labeled 0 to 2 pi, and they're evenly cut into 4 sections, going up first and then down to the middle and then down further to the bottom and then going back again. And it will keep moving in this pattern. You'll move to the top, down, and back like this. Okay, keep moving like that. And even for left hand side, I can't draw for left hand side, but for left hand side, it will be the same, like going down and up, down and up. So for sine x, the period is 2 pi. So what is a period? A period is the graph repeats in what length? Okay, so in every 2 pi, it will repeat exactly the same graph. For every 2 pi, repeat exactly the same graph. If you can see, if I move my y-axis here, that exactly looks the same as the second graph. So that's why if I move the first graph, pi on 2 unit to the left, I will achieve the cosine x graph. So sine x graph and cosine x graph, they are exactly the same thing. And for cosine x, it is 2 pi period as well. Because if you keep moving this, okay, I will have a new period. Okay, so that's 2 pi, and then the next 2 pi looks like this. So sine x, cosine x, they are kind of the same graph, but one is translate pi on 2 units to the left to achieve the other one. So sine move pi on 2 units to the left to achieve cosine x. That's why when we talk about transformations, I said only same type of functions can transform to each other, like log must transform to log, exponential must transfer to exponential. But the only exception, if you go back to chapter 7 notes, if you see there's only one exception, is the sine x and cosine x graph. They can transfer between each other, and that's why they can change to each other. They look exactly the same, and you only need to move left to right to make one to become the other. Okay, so that's from the transformation topic. Okay, so when you know, let's just write this down. The period, this is a sine x, this is a cosine x. The period for those two graphs equals to 2 pi. Okay, so in every, well, why 2 pi? Because you turn around in the unit circle, and then the next turn you will have exactly all the same values for all the same angles at the same position. So that's why we just turn around, we have all the values achieved, and then you go the next turn, all the value will repeat again. So that's the reason why we have 2 pi. But as you know, for all the graphs we learn in year 11 so far, like it doesn't matter hyperbola, truncus, we all have transformations. We move left to right, we have reflections. So same thing can happen for sine and cosine graph as well. So what's the transform? Well, I'm teaching this topic in a quite different way. I combine 3 exercises together. I directly give you the most complex form, and then we can work from the complex form to achieve all the questions. I don't want to introduce like dilation and then transformation and then right hand side, left hand side movement. So I put everything together for you here. The most complex form for sine cosine graph will be this. Okay, will be this. I will teach how to sketch sine cosine graph in a quite unique way. I never see teachers really teach in this way. See if you can get my method. I think a lot of you already learned this topic. If you feel your method is better, you can keep using your method as long as you can work it out. If you feel you find difficult to sketch it, try to see my method, whether that's suitable for you. Okay, so the complex form can be this. Okay, this is we can change sine to cosine as well, so they are the same thing. Okay, the t is same as x. Okay, the t is same as x. So what variables we have put? We can see first this a. Okay, so what a do is okay, just think about in general, not think about a circular function yet. You times a with the whole function, that's a dilation on y, right? You're stretching the graph this way or this way, okay, stretching it. We have this a. We have this n. What does n do? This n will stretch it this way or this way, okay? Do horizontal stretch. What this one will do is moving to the left or right. It's a horizontal movement. What this one will do? This one will move up and down. Okay, move the graph up and down. Okay, so something influences the width of the graph. Also, something will influence the height of the graph. Okay, A and B will be the value influence the height because B is moving up and down and A is stretching up and down. Okay, stretch taller or shorter. So A and B are influencing the Y values. N and this epsilon values, they are influencing the X values. Okay, stretch. Now, we consider that in circular function. Okay, in circular function. If you observe this graph got a minimum and a maximum. Also have a middle line as well. It's in between the maximum and the minimum. So what is the minimum? What is the maximum for circular functions? Okay. B, what B do? B is called the mean line. Okay, B is the mean line. Mean is what? Is the middle. So B is where's the middle of your graph? Okay, where's the middle of your graph? Okay, this is the middle line. So y equals to b is the middle. You don't need to sketch it, but like it's alright to just sketch a horizontal line on your graph. Okay, so you can sketch a middle, that's your middle. Okay, what's the next thing is, I will talk about this A. This A is called the amplitude. Okay, what is the amplitude? Amplitude will affect the max and minimum. Amplitude is how much it can move up and move down from the mean line. Okay, how many units you can move up from the mean line and how many units you can move down from the mean line. So this A can be negative. I can have -2 sign, but I will ignore the negative. I will only take the positive of that A value. So that's the unit I can move up or move down. So I will put absolute sign for A, that means the positive of A. Okay, that's the positive of A. So what is my max and minimum of my graph? Move A unit, that will be y equals to b plus the absolute of A. Okay, b plus the absolute of A. How many units you can move down? Like exactly the same unit, but it's y equals to b minus the absolute of A. And why I don't say minus A? Because A can be negative. So absolute is the unit, the absolute unit. So this is the three line the graph will move, okay, between. Okay, move from the mean to the max, back to the mean to the minimum, back to the mean and max. So that's where your graph will sit. Okay, three lines. That's the first thing you need to do when you sketch sine or cosine graph. Okay, find the middle, find the max, find the minimum. That's the first three things you do. Okay, if we can go to next page, not next page really, page 9. Okay, what I like to do is I normally sketch this three line out and to make my graph clear. Well, if you don't want to, that's fine. You just make a label there, like your graph should be here and here. So my middle is 2. Okay, the +2 is my middle. What I will do is I will sketch, well, I will use a blue color. Okay, that's my middle. These three decide whether it's max or minimum. So that's the going up and down. So from 2 going up by 3 units, you have this. And going down by 3 units, which is here. Okay, so I have 2 here, 5 here, and -1 here. Okay, my graph will be only in between those 3 lines. Okay, in between those 3 lines. let's go back. That's the first step you do when you see any sine cosine graph. Okay, the second thing is decide the period of this graph. Okay, n is pushing this way or stretching this way. Okay, it's like this. Okay, pushing or stretching. So the period will get effect. Okay, originally it's 2 pi, right? You get pushed inside, then it's not 2 pi anymore. Or stretched longer, it's maybe become 3 pi or 4 pi. So that is effect by n. Okay, that is effect by n. So what is the what's the way to calculate the period? Period equals to 2 pi divided by n. Absolute. Again, n can be negative, but we only use the positive value of the n. Okay, so it's 2 pi divided by n. You can work out what is the period. Okay, what is the period? Okay, so what is my period in this page? Period will equals to 2 pi divided by 2 because of this. Okay, this is affecting period. This 2, which is the coefficient of your variable x or t or anything given in a equation. So it's the coefficient. Is the coefficient of the variable. Okay, which is 2 in this case. So my period is pi. And my period is pi in this case. Now I want to introduce another thing which is normally not really shown. It's called the step. Okay, or step size. I'll explain what is step size. Step size is period divided by 4. Okay, always. Okay, which is period divided by 4. I will cut the period into 4 sections. You can see why when I go to the front page. So in this case, it's pi on 4. Okay, in this case, it's pi on 4. I work out my period and directly why I need my period because I want to see what each step I will take. Okay, what's each step I will take. Okay, let's go back to the normal sine graph now. Okay, the normal sine graph now. I'm not sure if you can see on my one clear. I have cut that into 4 sections as well with different colors and dashed line and solid lines. Okay, I said there's 4 stages. If you are someone working on this path, okay, if this is a path, okay, think about roller coaster, okay, moving up and down. You will experience 4 stages. Okay, from the middle, you will move to the top point. From the top point, you will move down to the middle point. From the middle point, you further move to the bottom point, and then the bottom point will make you move up to the middle point again. So what's your next step? What's your next stage you will achieve? Up, okay, and then minimum, and then mean, and then minimum. So you keep going with this pattern. But let's have a look. What's the height? I'm talking about the height from the middle to top, and then middle, and then down and middle, like it's the height. Let's think about the horizontal, how much I've traveled in the horizontal when I change from one height to another height. That takes period over 4 units. Because in each period, you will experience 4 stages. So each stage, the horizontal traveling will be period over 4. Okay, it will be, that's what for each height changing, what is the x traveling? Okay, the x travel period over 4. And then when x traveled period over 4, then your height will move from one stage to another stage. Okay, so that's the key idea for the graph, for my method to sketch a graph. Okay, so I know how x change relates to the y change now. Okay, now let's think about, this is a roller coaster with 1 kilometer long. Okay, just keep moving like this. Okay, it's not really exciting roller coaster. It's quite flat, like moving a little bit up and down. Like it's all the same. Okay, same changing. Okay, now you have traveling for such a long time already, and you're completely lost, like where I am. Okay, I don't know the whole graph, what the whole graph looks like. Let's think about if you are at the, like you are at the maximum point. Okay, what's the next point you will achieve traveling to? mean. Okay, so you know if you're at the top, you know you will travel to the mean. Okay, if you are at the bottom now, do you know where the next point you will travel to? Mean again, okay, and then max, and then like you can predict your pattern if you see I'm at the max or I'm at the minimum. So now you open your eyes, you're so scared, you open your eyes and you see you right in the middle. And you can't see what's going on like next. Do you know you will going up or down? Can you predict that? If you're completely lost, okay, just you open your eyes, you find you're in the middle of this roller coaster. Do you know whether you travel to the top point or the bottom point? Do you know you go up or go down? No, there's possibilities you can go up or there's possibility you can go down because you're at the middle point. You might go up, might go down. Okay, so now this is the important thing I want to say. Well, same as a cosine graph. Okay, same as a cosine graph. It's all exactly the same. The thing is, if I can find a point, if I know a point, it's definitely the maximum point of this whole graph. I can predict all the points after that. Or I can find the minimum point. I know, okay, for example, I know pi on 2, 1 is the maximum point for me already. I can predict all the rest because I can work out the period. I know what's the horizontal movement. I know what my vertical movement should be. So I can complete the whole graph. But if I just randomly find the middle point, I can't predict. Okay, I can't predict. So the key point to sketch a sine and a cosine graph is to find either a maximum point or a minimum point on the graph. After we find that, everything is solved. Okay, so find a max or a minimum graph point. Okay, so I want to, that's the whole paragraph what I'm talking about here. My pen's not working. Okay, so a max or a minimum. So okay, how to find the maximum? So I want to circle that. Okay, how to find the maximum? So this is the only difference between a sine graph and a cosine graph. So if you can see the next page, that's to sketch a sine graph. Okay, step 1, 2, 3, 4, 1, 2, 3, 5, 6. I have all talked about that. Let's have a look at 4. Okay, let's have a look at 4. I'll just save it.